Okay. I still got this terrible cold. I don't know what to do. I won't seem to go, so I'm having difficulty recording a um a lecture. But anyway, here I'm gonna try again. So in the last homework, we had these two lines of code which represent our use to create a a language for Boolean expression. So let me just get the interpreter started up and it can load this. I just chopped this out of the simplify code. So this just has the language and the parser and the pretty printer in it. But okay, so I'm going to load B expression. Oops. Okay, and that loaded. And so like in this data type represents the abstract syntax tree construction of Boolean expressions. So like, for example, if I don't write down the Boolean expression that just is P, I write down VP. Now, I wrote a pretty printer for this. I could say pretty VP, and it shows it to oops, I forgot the closing print. It shows it to you back as what you want. So in a way, the pretty printer is kind of like the inverse of what a parser is going to turn out to do. We're going to implement the things to build these data types. So like a more complicated one was inop and let's say VP and VQ. So, see, these things are really difficult to type in. So anyway, there's that one. But I could use my parser, and I have a function here called parse BEXP, which could take something like P, a string, P and Q, and it would generate that thing for me. If I typed in, Q and P, it would generate that one for me. So, for more complicated things like, I don't know, P and Q or if P then Q else R. Okay, there's the expression that I would have had to type in. So parsers are obviously extremely useful where you want to take a string representation and build a more complex a data type, but that data type actually makes it possible to do something like simplification. Doing simplification directly on the strings is really, just a path to insanity. So this code here that I gave you sort of without explanation is the parser for that thing. So that builds the parser for Boolean expressions. And we'll see how it works, and is what we're going to do is see how that thing works.